I'm Justin. I'm here with First Updates Now.
I'm Parker.
And today we are here at the Central Area Championships with 19746 SouthSTEM. So these guys have had an incredible season so far. They are the winning alliance captain of the Central Area Championships. Third Inspire, 166 OPR, 35-0 undefeated, and currently they have the Texas record of 338.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support.
I can't believe what you guys have done this season. So literally let's just start off and tell me a little bit about y'all's robot. Go around what it is, what kind of driver y'all use, your intake, your delivery, just go on.
All right, so I guess the biggest thing about a robot, I guess that's different from a lot of other teams, is we're a tank drive. If you want to show that. It's pretty standard tank drive, but I know it's kind of uncommon at FTC now, but we actually, when we were reviewing the game, we noticed it was kind of like Skystone, and that had a lot of robot contact near the human player station, so we kind of wanted the extra pushing power for that. You want to continue on our horizontal slide, bro?
Yeah, so one of the downsides of six-wheel drives is that we can't strafe, or like Mecanum, we can't have holonomic motion. So we iterated our lift subsystem so we can move both in the horizontal and vertical directions, which has allowed us to easily manipulate mosaics and score lots of points.
And we work with partners well with it too, so yeah.
Yeah.
I guess the next question I have, there's mainly two different types of intakes this season. You could have an active intake with rollers, or you could have a cloud. What made y'all go with the active intake this season?
Yeah, so the main thing we wanted from our intake was consistency and reliability, and for it to be easy to intake. And the main drawback with the claw is that you have to be accurate in both IntelliOp and auto with the claw. So, however, with an active intake with these spindles or rubber tubing, you don't have to be as accurate, even if it's especially if it's wide. So that's why we decided to go with a very wide active intake, which uses custom silicone tubing that we made by 3D printing silicon molds and then pouring the silicon in there and then letting it cure.
Yeah.
Yeah.
And then I guess the next question we can go into is y'all's hang and endgame kind of mechanisms, your drone, and just your hang in general.
So our hang mechanism, it basically uses a central axle which runs through our robot, and at the start of matches, to put it back in and out, we have to use an Allen wrench, or I don't know, I'm not a hardware person. I don't know why they gave the phone to me. I do software. But I'm gonna pass it to Nav now because I only know software.
Yeah, so we use a high torque motor to power our linkage-based hang system, and after we spool it out, we just spool it back in, and then we have 100% consistent hang. It's pretty simple. And then for our plane, we use a spring-powered mechanism, which has proved very consistent for us, as springs don't lose their tension as quickly as rubber bands over time.
So at the beginning of the season, we actually used a rubber band, but it applied directly to our plane, which caused the back of our fuselage of the plane to kind of deform a little bit. So in this design, we have a spring that controls a tab so that there's more surface area, so the force distribution is more even, on the fuselage of the plane, which prevents that plane deformation. Also, the rubber band definitely loses its tension over time, whereas the spring is a lot more resistant to that. So, yeah.
And how consistent has y'all's drone been so far?
It's been a journey so far. We got a lot of ups and downs with the plane. So being brutally honest, not the greatest consistency, but we're working on it. We're working on it.
It got 0 points in 2 of the elimination matches.
Tough, but it's okay.
So continuing with the mechanical aspect of the interview, one question I think a lot of people just might be curious about is like what kind of RPMs y'all run on your different systems on your intake and delivery?
Sure. So for our drivetrain, we run it's a tank drive. So 4 motors for the drivetrain, 2 for each side, 3 12s. They're geared down 60 to 48, so 5 to 4, which I think comes around to around 14 or 15 to 1.
Yeah, it's like 15 to 1.
Yeah. And then for our lift, we have 2 1150 RPM motors.
And then for hang, we have a 51 to 1 motor.
Yeah, and then we also have another 1150 RPM for our intake, which is, yeah.
All right, and I had one really interesting question for you guys. So why did you guys decide to use wood as your main chassis?
Yeah, so we have like 4 people and we work out of a garage and like we don't have like a CNC that can cut anything besides wood and plastic, and we ran out of time to do plastic this comp. So it's like not plastic. What's it called, bro?
Yeah, it's called HDPE. It's basically
Okay, it's basically plastic, but we were gonna do that, and then we're like, it'll be fine. Let's just keep wood. So
there are tactical benefits to wood.
oh yeah,
Because like it decreases overall static, because it's easier to put on like the static the tape protecting the robot from static on the wood compared to plastic. And then also the thickness of the wood is a bit smaller than the HDPE, and that protects us from
Going outside of 18.
from going outside of 18.
and then we also get to look like the World's Division Design Award winning team, Quadex 6299. Shout out to them. They're a real one.
So are y'all planning to change it, or are you guys gonna stick with the wood all the way up until Worlds?
I think that's a mystery.
Yeah, you'll see it state, bro. You'll see it state. Maybe Worlds. We don't know if we make it.
One more thing. So I know y'all just mentioned your 18 by 18. Is there any plans to maybe get smaller than 18 by 18 at any point?
So like, if you watched finals, there was a lot of contact between us and 12928 Lightsiders, and they have a robot that is aluminum and like 10 pounds heavier than ours, but we were winning those engages. And I think part of that is just due to our size, more mass, 6-wheel tank drive. So I think the size kind of helps with the tank drive, especially if you're going for like a contact-oriented play style.
All right, and let's move on to sort of the programming side of things. So can y'all tell me, like, do you guys have any sensors, and how do you use it for your robot and such?
Yeah, so from basically early January, we kind of stopped all pathing changes basically, and we just started adding more sensors to make stuff reliable. So like our intake, we use a velocity sensor, like we just get the motor's velocity, and if it's like low into auto, we know that it's jammed and we'll spit pixels out. And then we also use 2 ultrasonics right here to relocalize every time we're at the stack, which has greatly increased like our auto consistency, like no matter what field we're on. I guess we just do general current sensing to make sure we can shut down if our current's getting too high, just because that's like kind of bad. What, Jeff?
Positional based air shutdown as well.
Yeah, we also we have we use driving coders for our odometry, and then obviously if we're too far from our target, we'll just shut down our auto, stop driving. Yeah.
And then also with the utilization of our horizontal slide, like obviously when we pair that with our localization, like there's still gonna be some air. But as long as the localization knows it has air, we can actually use like our horizontal correct for like X direction air, which has helped us increase the consistency of our yellow pixel for those like big 20 points. I guess another thing as well is like at our most recent competition before this at our league champs, we noticed that like we had like a 2+5, and so we were super happy about that, but we were kind of frustrated that we kind of had to tell all of our partners not to run their auto because like the backboard is like 24 inches. It's hard to kind of coordinate. So what we've been working on since champs is we've been able to make our auto a lot more configurable. So we actually have around like 150 different unique autos that we can run, not counting like configurable delays, which could be like infinite. This involves like being able to choose like what yellow pixel slot we use with the horizontal, each vision case, whether or not we want to go backstage or backboard for each cycle, stuff like that. And so, especially for today, we didn't really have we didn't know if we had an auto that worked with our two picks, Bobots and Iron Eagles Prime. So having that customizability like really allowed us to change things super quickly to actually get working autos with them, which has clearly paid off because we got the auto world record. So, yeah.
And a Texas State record.
And then Texas State. Yeah. So I had a question for y'all. So what are y'all's plans for the autonomous? I know you guys probably want to do more than that. And how are you guys going to make sure that you ensure that, you know, if you guys are going to do like a 2+8 or something in the future?
Yeah, so, I mean, I'm not saying, like, maybe we have more, maybe we don't. You never know. But right now, our robot's max acceleration is 85 inches per second squared, and the max velocity is 65-ish. It's technically higher, but we have to sacrifice acceleration. Our auto only goes up to like 35 because our velocity controller could use a little bit of work. Because like we don't use Roadrunner or anything. We're completely custom. Over the summer, I kind of just like took a drivetrain home and thugged it out for a few hours. Not hours, a few like weeks. But, you know, tank drives are kind of hard to make autos for. But so, yeah, we're just hoping to get a few more cycles in there maybe.
Yeah, and I just want to ask, like, what's y'all's like primary like motion pathing? Why did y'all decide like not to use Roadrunner anymore? And is there anything better than that?
Yeah, so over the off season, we're like, well, it was really at the end of last season. We're like, was there really a year besides power play where a tank drive isn't like better if you can account for software differences? And we're like, we don't really think so. So we knew we kind of might want to use a tank drive coming to the season. And we're like, okay, a huge step back to that is obviously Roadrunner is. No offense to the people who made Runner, they're very smart people, but Roadrunner on tank drive does not work the greatest. There isn't very many good open source tank drive solutions. And so we're like, okay, that might be a little bit of a drawback. So we talked to the greatest autonomous team of all time, 6Stone Auto, Data Force, and we're like, hey, how did your Pure Pursuit work? Because a lot of people think that Pure Pursuit's like a library that you download. It's not. Just like PID, it's an algorithm that you have to implement yourself. There's a lot of variations. If you want to learn how to do it, don't like search YouTube, FTC, Pure Pursuit. Find like research papers or talk to people who have done it. But that's what we did. And they told us how they did it, and we like implemented that. And we've made a lot of changes over the season just to make it a little bit better and better. But that's something we might want to keep iterating because we definitely think that with the correct Pure Pursuit algorithm and like error correctability, we can get a very, very, very big auto.
I had a quick question. So there's April tags on the backboard. Are y'all gonna plan on using that? And if so, how are you gonna do it?
So actually 2 days before League Champs, we're like, we should maybe actually put those up and like see if they're any good. And they were pretty decent. So we haven't really thought of any big usage we could use them for, or we thought of one, but like we might do that. You can see it states if we do it. But right now, the ultrasonics kind of carry a lot of what the April tags would do, just relocalization. And maybe in teleop to identify, like, because obviously localization does drift over time and it's kind of hard to relocalize with ultrasonics and teleop. So we maybe would use them in teleop for like automation stuff, but I don't think we're planning to use them too much in auto right now.
Well, this is BrainSTEM, guys. SouthSTEM 19746. Thank you guys so much for letting us interview, and I hope to see y'all at States and hopefully Worlds as well. All right, thank you so much, guys.
Thank you.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply.